This is the video lesson for 2.4b, dividing polynomials and the factor theorem. Yesterday we saw in the remainder theorem how we could use synthetic division to evaluate a function. So you can see the same theorem again, and you can see our problem. It says to evaluate a polynomial function, you can use either direct substitution or synthetic substitution. Of course, in our lesson here, we want to be evaluating using synthetic substitution. If you look at problem 1, I've shown you direct substitution in case you've forgotten what that looks like, where I input 3 each time the variable x occurs in the function, and you can see we've gotten 98 as our outcome. Now, I'm going to erase that and do the same problem using synthetic substitution. And of course, that will look a little different. I'm going to first set it up like synthetic division, and I'm going to put 3 in the half box, and then putting my coefficients going across, I'd have 2 for the 4th degree term. I do not have a 3rd degree term, so I'm going to put a 0. Then -8 for the squared term, +5 for the 1st degree term, and -7 for the constant term. And then I'm going to draw my line, and then draw my line for my remainder, which really is my answer in synthetic substitution. And then I'm going to start doing my synthetic division. So I'm going to drop down my leading coefficient, multiply the number in the half box times my leading coefficient, which is 6. Then I'll add, I'll multiply again, and I'll add, multiply, add. Oops, I meant to write 30. I was writing the answer already. And then 3 times 35 is 105. And then I'll add, and again, I get the same answer. So the interpretation, of course, is that f of 3 equals the remainder 98. That is synthetic substitution. So just wanted to show you that so that you understood, again, how that compares to direct substitution. Now, the factor theorem that follows actually is a form of this. The factor theorem says let f of x be a polynomial, and it says if f of c equals 0, basically meaning if you do synthetic substitution and the remainder is 0, that has to mean that the factor x minus c went in evenly to the polynomial, and therefore is a factor of the polynomial. And it also goes the other way. If you know something is a factor, then f of c would have to be 0, giving you a remainder of 0. So let's look at our problem. It says solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0 of the function. An alternative to saying that would be to say the factor is x plus 1, because if the factor is x plus 1, then the value of c would be -1. Again, that's because this would have started as x minus a -1. And so as a result, if we do synthetic division, you can see I've set it up. I put -1 in the half box. That's the value of c, or the root if the factor is x plus 1. And I'm going to go through, I'm going to drop down my leading coefficient. The product, of course, is -15. When I add, I get -1. Multiply, I get 1. When I add, that is -2. When I multiply, that is +2. and as a result, I get a remainder of 0. So since -1 gave me a remainder of 0, that has to mean that -1 is a root or 0 of the function, and the factor associated with that 0 would be x plus 1. So as a result, I can really write this polynomial in factored form. And, I originally had 15x cubed plus 14x squared minus 3x minus 2. But now, if -1 works and gives me a remainder of 0, the factor then associated with that is x plus 1. And then the result from the synthetic division would be 15x squared, 1 degree less than what I started with, minus x minus 2 equals 0. So that's the factored form that I have based on my results of synthetic substitution. Of course, what I'm left with is a quadratic, so my hope is I might be able to factor it. Of course, if it doesn't factor, I can always try quadratic formula. I'm going to go with 5x and 3x, the pair of factors closest together. Now, I'd have to try 2 and 1. I need the difference of my outside and inside factor or products to be 1, since that is this middle term. So if I plug in, if I put the 2 in the second slot, I'd get 10 and 3, 10x and 3x, and that's going to have a difference of 7x. If I put the 2 here and the 1 here, I'm going to have an outside product of 5x and an inside product of 6x, and that would have a difference of 1. Signs have to be different. I need it to be a negative 6x and a positive 5x so that I can have the middle term being negative 1x. At this point, I can now write my zeros. They're -1. If I set 5x minus 2 equal to 0, does it make sense? That's going to give you 2/5. And if I set 3x plus 1 equal to 0, that would be -1/3. So the solutions, which how they're going to write it in my math lab, is going to be in set notation. I think they might want it from smallest to largest. So that'd be -1, -1/3, and positive 2/5. You'll have to see if that's the case. But that concludes our examples. You're going to have some review. I think I gave you a couple long division, a couple synthetic division, a couple synthetic substitution, and then a couple at the end like this last one of which might be a graph. The other thing you also have is the review worksheet. Don't forget, in addition to 2.4b, you want to complete review worksheet 2.4, which the substitute should give to you. All right, have a good day.